Welcome to Study Loop.
In this problem, we're asked to find the total binding energy per nucleon of a nitrogen 15 isotope. I've gone back to Appendix B and looked up the masses for each of the nitrogen 15 isotope, and it has a mass of 15.000109 atomic mass units. And we're going to need to subtract that amount from the total mass of its constituent protons and electrons when taking their masses individually. So that will give us a delta M using this equation below. There are 15 nucleons inside this isotope, 7 of which are protons, 8 of which are neutrons. And we're going to subtract that by the atomic mass of the nitrogen isotope itself. But a crucial thing to remember here is that part of the mass of this nitrogen isotope includes the mass of the electrons. So we're going to have to account for those in order to find a proper change in mass. What I've done below is to regroup these terms such that the mass of the 7 electrons that we need to subtract out, we can subtract out a negative, which makes it become a positive, and put it over here under the beside the coefficient of 7. Notice that this mass of a proton plus an electron is the equivalent of a hydrogen atom. And that is what we have that here. I've listed under the individual masses for each of the constituents involved in the calculation of delta M. Turns out that after this regrouping, we won't actually need the mass of the proton alone. It's more convenient for us to use the mass of a hydrogen atom because that includes the mass of an electron. So if you plug in these numbers here, you'll find that we have a delta M of 0.1239 85 atomic mass units. We can multiply that by our conversion factor, which I wrote it up top, of 931.5 megaelectron volts per atomic mass unit. And so we'll do that here. Oops. Which leaves us with a figure of 115.492958 mega electron volts. The problem, though, asks for the total binding energy per nucleon. So this delta N that we've calculated, mega electron volts, we need to divide by the atomic mass number of the element in question, this nitrogen isotope, that atomic mass number is this 15 in the subscript. So this is equivalent to our 115.49298 mega electron volts divided by 15, which gives us 7.699 or 995 mega electron volts binding energy per nucleon. And that's our answer.